Hello, welcome everyone to a new video by Conistics.com. So today we are discussing a new library in RStudio that can be help in reducing the time to store your data considerably. So I came across this website maintained by World Bank. It's TC Data360. It's a initiative by the World Bank uh, to provide a platform which several softwares can access and get data rather than we download the Excel file and transpose it and arrange it for our needs. So you can just access from your software so that it can be easily maintained. So I will show you how to get it using RStudio. So here we can see that there are the library that is required to access the data is the DevTools, and the library is actually Data360R, but that library is not available easily. So it's you need to access the GitHub website. For that you need to install DevTools. So install DevTools, and using the DevTools I'm accessing the Data360R library. So if I execute, so it will install the library in the computer, and it is shown that the library has been successfully it's installing. And okay, so the library has been installed. So using now we need to use these three libraries. Use this DevTools and Tidyverse. So DevTools will help you to access the data file, and Tidyverse is to data management. And when I execute it, the libraries have been loaded. Now first, since the data libraries are there which are used to access the data, now we need to access the catalog of what kind of data sets are available. So for that, the command is the data catalog is equal to Data360R. Using a library, get the metadata 360 data type datasets. So it will give me all the datasets, names of the datasets which are available there and their codes. If I execute, you will be seeing it is downloading, and you can see there are this is the data file. So if I open it, so all the data files, data libraries are here. If I let me, so you can see all the data sets. So this code is used to download this data, and there are so many. Says the most commonly used in economics is World Economic Forum and Global Competitiveness Index and WDI. Okay, you can find WDI and World Governance Indicators is very common, used in economics. And so there are many databases that are popularly used, uh, commonly used. It's up to you which data file you need to download. Today we'll be downloading one data file and discussing how to manage it for your estimation needs. So today we are downloading the World Economic Forum Global Competitiveness Index data file, and the for that the data code was 53. So and now so WEF data is equal to Data360R, get the data set, and the dataset ID is 53. So when I execute it, it will access the platform of World Bank and start downloading the data file. So it will take some time because the data file is big. Here you can see the data file has been loaded, and if I select it, you can see the country codes, country name, indicator codes, indicator names, sub indicator type, and years of data available. So first of all, the data is loaded. Now you need to understand what is the required type of data sets that is commonly used in panel data setting. So what is the standard that softwares use when they estimate panel data? For that, there's some presentation that I would like to share. So here you see that the tidyverse author Garrett have defined data set that can be used in R for panel data is as tidy data. So data come, according to him, data come in many formats, just like we downloaded right now, but R prefers just one, that is tidy data. So in order to estimate it properly, especially panel data models, you need to convert it into tidy data. So in econometrics, the tidy data is actually the standard setting for panel data. It means we need to convert it into tidy form. So what is the tidy form? We will go here. So the properties of tidy data is if data is tidy if and only if each variable has its own column. Means if the variables include country name, years, dependent variable, independent variable, control variables. Each variable should represent in its own column. Then each case means for each variable there will be a case observation. It should be for each variable should have its own column. So each case should have a own row, and each value has its own cell. So a value should not repeat in more than one cells, or some of the values should not be omitted. So these are the properties that are required to ensure the data is tidy or usable for panel data. Now we look at it here in our data file. So our variables are not in columns, they are in rows, and the countries are also here. Country name is already in a column, variable names are not in a column, years are in a row. They should be in a the indicators should be in each variable name should have one column, and there should be a column of years where all the years should come. It means we need to transpose the indicator column, these variable names, from column to a row, and the years from a row to a column. So if we don't use RStudio, it will take ages, because transposing two of them simultaneously takes a lot of time. So this video today will tell you how to arrange the data file quick enough using RStudio. So first of all, you need to remove the useless columns. For example, the indicator type is useless for our data analysis. The indicator ID, maybe it's useless, and the dataset ID, it's useless. So what we'll do, we will ask first of all that remove indicator ID. Uh, filter the data where indicator ID is less than 41000. Why we are doing it? Because for my example, there are some few variables which are at the end where indicator code is above 4000. These are the variables which are only available for the last 3 years, but not for older data. So I don't need it, because if I use it, the data will become very short. So I am excluding these row cases. So if I need to exclude cases, I will use the command filter. So new data file is equal to old data file, and filtering some of the rows, and also every variable has 2 or 3 types. For example, market sizes, rank, and a value. We only need value, so I am filtering it that only give me which is not equal to rank, keep it, and others remove. So when I do it, it will reduce the rows, because I am removing the rows which have indicator ID more than 41,000 and which are equal to rank. So you can see the new data file. It original one has 96,000 observations, it has only 18,000. So data file has been shortened. So I will open this one. So you can see the data file is shortened. Now the next command I am using is that I will remove these 2017 and 18, because you can see at the end there's also already 16 17 and 17 18. So I don't need 17 and 18 because there is no observation in these columns, so it's already empty. So if I do it, and you can see, and I'm also removing dataset ID and sub indicator type, and the minus sign is showing that remove them and keep all others. So if I remove them now, in the previous case I was removing rows, so I was using filter. Now I'm removing columns, so I will use select. So when I run this, it will be make a new data file wf2. Now you can see the previous case there were 20 variables, means 20 columns. Now there are only 15 columns. So here you can see the files which are not required are removed. So data file is more neater. Now need to do is that I need to make a, if I remove this one, so I need to make a column of years and move all of these years from columns to rows. So what I will do, I will use the command gather. So gather command is used to convert the columns to rows. So I will say new data file wf3 equal to wf2 and gather key year. So make a new column which name is year, and I will pick I will what I will put there, all the observations. Observations are these numbers, and it will start from 4 to 14. How I know this? So I can see from here. So there are 15 columns. Okay, so what I need to do is I will pick it from, was it 1 2 3 4, from 4th to 15. So what I will do, I will select from 4 to 15, and 4th column to 15th column I will pick it up and convert it into rows. So I will do it 4 to 15. When I do it, you will notice that in the new data file wf3 the observation have increased and variables have reduced. So if I select wf3 and close it down, you can see that there is country codes, country names, variable names, years, and observations. So what has happened, that the columns for each year has converted into rows for each year. So the data, the first problem has been solved. The years are converted into year, columns are converted into year rows. Now second thing we need to solve is the variable rows into variable columns. So that will be done using spread command. So for that I will say wef is equal to wef and spread what it I will spread the indicator column and pick observations relative to them. So if I execute it, you will see there is a new data file. First of all, I will close the old one and select the new one. So you can see there is codes, years, names, years, and all the variables are now as columns. So if you go to the slides again, you can see each variable has a column, each case has a row, each value has a cell. So we can see it here. Each variable, which is country name, year, and variables, have a column. Each case has a row. So it means every there are if the data is for 10 years, it means each country has 10 cases. So there are 10 rows, and then similarly, and each row has its object. So this value is not repeated anywhere else. So this data is tidy. So now what you need to do is, first, next thing is that other things that you can do is, so there's one case in 2019, others are in ranges. So what should I do is select the second one. So how I can do it, that I will select a new data file where we have separate is as a new variable where s year and separate it based upon the dash. So I will select the column here, and I will separate the column based upon the dash sign, and the first one will become starting year and second one will be the ending year, and I will say that remove the starting year. So when I run this, there will be a new data file. If I open this, you can see that the years column has been corrected. The problem is that the last one has been removed. So what we can do is that we need to make sure that when we are separating it, so we need to adjust it accordingly. So secondly, since this data file does not have any observations for that year, so what we could do is, so we can remove that year from the data. So here we can add another column minus dash 2009. So what I will do it here is, when I execute it, it will remove the 2009. So wef2. So using the previous command again, I will remove the 2019 and then do the remaining steps again. It will just overwrite the data file So I will do it till 2014 because one of the year has been reduced, and then I will do the next command and the next step. So you can see here is that the last file WEFC1, there the years have been sorted. The 2019 has been removed because in the data file the rows are empty, so no data is available there, so I just remove that row. Lastly, if you want to reduce the variables, what you can do is data file 1 is equal to WEFC1 and select country name, years, and the variable that you need. Note here that I'm using this commas, overhead commas. The purpose of these is sometimes the variable name have a space. If the variable does not have a space, you can leave them, otherwise you need to use them. So I have selected these 5 or 6 variables. So when I execute it, so then the final data df1 has 4 variables and one country name and one year. So this is a smaller data file. Secondly, you can do is if you want to store this data file into R format, this is the command save RDS, and it will give it a name. So our data file is df1, so I will write here def1 and then the file name you want to save. So if you do it, it will be saved in R format, and if you want to read it, so I will use R read underscore RDS def1. So this way you can pick the data file. Secondly, what you can do is that you can store it into CSV format. The command is write CSV write CSV def1 and file name that you want to keep. So I will write WEF data. So it will convert the file into CSV format, and you can then use it in any other platform or present it to anyone else. This way you can. So this video was about how to access data from online portals. The conventional way was to open their reports, type it yourself, and then do the appropriate transformations. It usually takes days to convert the data, but here we took only 10 minutes to convert the data into appropriate format. Thank you very much for your watching. Hopefully this video will reduce the time taken by you to collect the data and convert it into usable format. Hopefully you will visit again. Thank you very much.